So let's start the lesson today. And today is a bit of a transition lesson as we move from straight line functions to quadratic or functions or parabolas. And just to remind you what we did in the last lesson, we spoke about straight line graphs, which have this format. And an example would be something like that. But we also saw some straight line graphs that might have been in the format like that. You know, but as long as we have powers of 1 on the variables, we're going to get straight lines. We also spoke about finding the x-intercept and finding the y-intercept of straight line graphs. And just to remind you how we did that, for the x-intercept, we make y naught. For the y-intercept, we always make x naught. And so that's an important idea that we use throughout functions and relationships. And then we also spoke a little bit about something called intersection points. So intersection points are where if we have two graphs and they meet, so let's say I have a straight line like that and a straight line like that, then this point over here would be the intersection point. And we learned about how we can use simultaneous equations to help us find what that point is. Now, as we deal with other types of functions like the parabola, you will find that instead of having just one intersection point, if you have a parabola and a straight line, you can have two intersection points. And so we'll talk maybe a bit today about how we can find those points as well. Okay. Just give me a thumbs up if this all sounds vaguely familiar. Thumbs down if you feel a bit like, whoa, what is this man talking about? Just want to quickly get some feedback before I move into the lesson. Okay. Oh, we also spoke a little bit about something called f of x notation and how we use that. So on to lesson number 2. Okay, so if we want to know what the difference between a straight line and a parabola is, the main thing we're going to look for that's different. So let's say this is a straight line in sort of normal notation, and this is that same straight line written in f of x notation. If I want a parabola, let me start with the y notation. A parabola is the graph that we get when we have a equation or a relationship with an x squared term. Now, it can have numbers in front, and it can have terms with the power of 1, and it can have a constant term. But the main thing we're looking for to make sure that we get a parabola is we're looking for that x squared term. And using the same notation, g of x equals 3x squared plus 2x plus 3 would be the way of writing that same parabola, just using the f of x, g of x notation. Okay, so let's just check if you understand how this f of x, g of x notation works. I want you to find me the f of 1 plus the g of 1. So looking at what's on the board and using what we spoke about at the end of the last, maybe I'll give you a cheat. I'll give you the f of 1. I'll show you how to do that, but you need to find the g of 1. So the f of 1 would just be that, which would just be 3. But I want to know what the f of 1 plus the g of 1 is going to be equal to. You can pop your answer in the chat, or you can raise your hand if you like. So we've already discussed that the f of 1 was that. But what's the g of 1 going to be? Well, let's move this away. The g of 1 is going to be 3 times 1 squared plus 2 times 1 plus 3, which is going to give me 3 plus 2 plus 3, which is going to give me 8, which means that I have 3 plus 8, which gives me what? The f of 1 plus the g of 1 is 11. Yeah. And so the reason in mathematics, it's not, you can switch between these two ways of writing something, right? So when we do this as well, but a lot of the times we really like using the f of x and g of x notation because it's so quick and efficient to tell you things. And so it's important that you understand that what f of 1 or what the g of 1 means as you come across a mathematical paper. Okay, cool. Then let's just go on to identifying functions. So there's different types of functions. I know that you haven't covered all of these in grade 11 yet, but you would have seen the shapes, I think, before. I want you to identify the different types of functions in this picture. So A, B, C, D, E, and F. And maybe somebody who feels brave can give me 2 of them. So you can come online or you can put it in the chat, but tell me, could you identify 2 of these types of functions? Let's go to Simpiwe. So Simpiwe, what 2 would you like to identify?
So I would like to identify my A and B.
Okay, what is A?
A is a hyperbola and B is a parabola.
Yep, you are absolutely correct. Perfect. Thank you very much. Let's go to Kat. So let's go to Kat. Kat, what do you think? Which 2 would you like to identify?
I would like to identify F and C.
Okay, what is C?
C is a straight line.
Perfect. And what is F?
And F is an exponential.
You are correct. Thank you very much, Kat. Let's go to Tebogo. Tebogo, what do you think of D and E? Could you identify either of these 2?
D is a parabola with the negative concavity, and then
Okay.
E is a hyperbola.
Perfect. Thank you very much. You guys know your functions. So just to point out a few more things that I often talk about this being a happy parabola because it kind of looks like a happy face. And the thing that makes a parabola happy is if the number in front of the x squared, so let's say if I have a parabola and it's got ax squared plus something, that a has to be positive to be happy. Whereas if we look at this one over here, I often think of this as an unhappy parabola. And in this case, the number in front of the x squared would have to be negative in order to be unhappy. So that's useful to know. The other thing I want to point out is that if we look at parabolas, they kind of are symmetrical through the turning point. You can kind of cut them in half on the turning point, and they're symmetrical. They have an axis of symmetry, so that's useful. When we look at hyperbolas have these things called asymptotes, these dotted lines that we can't cross, so that's important. They also have axes of symmetry, but I'm not going to go into that right now. And then the last one over here, F is an exponential graph, and it looks like a little bit like something just taking off. And we're going to do lessons on those, I think, in 2 weeks' time. But for now, I just wanted you to make sure you knew what parabolas looked like roughly, and we're going to focus on B and D today. Okay, so let's just take a little bit of a deeper dive into parabolas. So the simplest parabola that I can think of is y equals x squared. And, that's quite a simple graph. It's actually going to have its x and y intercept is going to be at that point 0, 0. Okay. Now, I want you to take the simple parabola, and I want you to shift it down by 3 units. What will my new equation be if I shift it down by 3 units? I want you to put it in the chat, or maybe you can come on and tell me how would you shift the most basic parabola down by 3 units? So if I shifted it down, it would become the equation x squared minus 3. And if I had to visualize that, it would be like this dot moved, say, down to here. And now I guess the graph would look something like that, if I'm guessing. How about you find me, I want you to find me the x-intercept and the y-intercepts or sets of this graph. So using what you've learned so far in relationships and functions, find me the intercepts of this shifted graph. So what would my intercepts? So yeah, the y one is probably the easiest here. It's going to be minus 3. What about the x-intercepts? They're going to be here. Okay, so we've got the y-intercept as minus 3. How do we find the x-intercept? I think we have to make y naught. And so we start with that. And then I would bring the 3 to the other side. So I get x squared. And then if I square root both sides, I get that. But when I square root, I get plus and minus. And so this one over here is going to be square root 3 or 1,58 or something. And this intercept over here is going to be minus square root 3. And so that is an important idea. When we shifted this down, we now have 2 x-intercepts or 2 cuts with the x-axis. Give me a thumbs up if finding the x-intercept like this and the y-intercept like this makes sense to you. Give me a thumbs down if you're unsure in any way. So we took the most basic parabola that we knew about, and we shifted it down by 3, and that's fine. Okay. Fantastic. Now, shifting it down by 3 units is fine, but what if I said to you, I want you to take this original y equals x squared, which is the simplest parabola, and I want you to shift it 2 units to the, let's say, to the left. So 2 units to the left. What would my new equation be? So I'm ignoring this one. We've done this one, and that was a vertical shift. I want to know if I go back to the original and I shift it 2 units to the left, if I want to move it in that direction, what would the equation have to be? It's a bit of a sneaky one. I want it to end up like over here somewhere, I guess. So students are telling me that I need to write it as x plus 2 squared. And I agree. But just to make sure that we're all right, I want you to find me. Let me just bring this back into picture. I want you, so you've made a claim, and I think you're right, but let's just check. What is the y-intercept of this graph, and what is the x-intercept? And I want you to work out the intercepts for the shifted graph for me. So over to you guys. Work out for me the intercepts. I guess it would look, if we've done this correct, okay, it's not going to be minus 3 anymore. We're going to find out in a moment, but we want it to look something like this, I guess, because everything has been moved 2 units to the left. So pop your answers in the chat there. Ipileng. So what we're doing is students have made the claim that to shift the graph, if I want to start with the original graph, y equals x squared, and I want to shift it 2 units to the left, which is what I was asking. Students have claimed that I should make this parabola y equals x plus 2 squared. And I'm saying I think that's right, but I want to check that you know how to find the y-intercept and the x-intercept of this parabola to check. And what I'm going to do is to find the y-intercept, I need to make x 0. And so I agree the y-intercept will be 4. Now to find the x-intercept, what do I have to do? I normally have to make y 0. So we have to solve that equation. So what I could do here is x plus 2 squared. I could square root both sides. And if I did that, I'll get x plus 2 is 0. And so then x must be equal to minus 2. Now, as I look at my graph at the top here, it looks like students have correctly shifted the graph to the left because my x-intercept is minus 2, which is here, and my y-intercept is 4, which is up here. And so that makes sense to me. The first graph we did now, we shifted it down. This next one, we've shifted it across. And so it feels like all is well with the world for now. Some students might be a little bit confused, and that's fine, but it looks like we're on the right track. And I just want to point something else out to you. I didn't do this, but I could have rewritten this graph as x plus 2 times x plus 2. So just take a moment to see, do you agree with that? And then if I wanted to, and I didn't need to, but I could have multiplied this out. And so one of the things we need to be sort of interested in is that parabolas can be written in different forms. So we call, if I multiply it out and I write it like this is called the standard form of a parabola. And this form over here, although it's not completely here, is sometimes called the alternate form of a parabola. They are the same thing, but I just want to make sure you're aware that you can change, these are the same things. So just give me a thumbs up if you understand why these two are the same thing. I just want to make sure you're clear on that before I move on. So the correct equation is x plus 2 squared. And x plus 2 squared is exactly the same equation as y equals x squared plus 4x plus 4. That's what I'm trying to emphasize. And also, just to let you know, going from y equals x squared down to this one is visually like going from the green graph to the black graph and just moving across. That's kind of what I'm trying to show you. Okay, last thing before we go to the break. We're starting out life with f of x equals x squared. But I want to do 2 shifts. I want to shift down by 1 unit, and I want to shift right by 2 units. So, and we'll call the new equation, we'll call it g of x. Find me my new parabola if I shift down by 1 unit and I shift right by 2 units, and I want you to use the working out that I have on the screen right now. We don't need this bit. That bit, it was just a little bit of extra. Komotso, let's go to you. What is your question?
So I wanted to answer, but
Oh, okay. Well, tell me the first part. Where would you start?
so I would say g of x is equal to open brackets x minus 2 because we moved right by 2 units.
Perfect. Yeah.
And then I would say close brackets minus 1 because we moved down by 1 unit.
Perfect. I couldn't have said it any better myself. So to do this shift, this going for, if I apply this shift, I get that one over there. Now, what I want is this is what we call the alternate. There's different ways of writing parabolas. This is called the alternate form. I want you guys to write this in what's called standard form. And the way you're going to need to do that is you're going to need to break apart this bit by multiplying it out. So over to you. I want you to find me the same graph, but just in its standard form. What's this going to be? Okay, so now watch out because it's not going to be a +4 on the end. It's going to be a +3 because of that -1. Oh, it's not -3 because when I multiply the -2 by the -2, I get +4. But then when I take away the 1, I get the 3. Okay. All right, one more thing before the break. I want you to find me the y-intercept and the x-intercept of this function. So find me the y-intercept and the x-intercept of g of x. And you can use either of the forms because they're the same graph. So feel free to use the alternate form or the standard form. Either of these will get you the right answer, but I want to know what the y-intercept is and what the x-intercept is. And then we do a break. How do you know? So Tando has asked, how do you know when to multiply out the bracket instead of squaring both sides? So you can do either. I'm forcing you to do both today because I want to make sure students are aware of both forms. But you can choose whichever one is easiest to you. Both will always get you to the answer. It's just a question of which one is quickest. And that kind of depends on the person who's doing it. So yeah. Why did we -2 from this example, but you -1 in this one? Okay. When we are shifting horizontally, so when we shifted 2 units to the right, this 2 units was this transformation. That is shifting it 2 units to the right. Whereas when we were shifting it down by 1 unit, that's going to be this -1 here. So it's all about the way the shifting works. The horizontal shift almost works backwards. It's like if you want to go to the right, you need a minus. Whereas if you want to go to the vertical shift works kind of normally. All right, so let's see. So the y-intercept for me would have to be 3. Or if I was writing it in full form, it would be 0, 3. What about the x-intercept? what's that going to be? There's two ways. Remember, whenever we want to find the x-intercept, I'm going to use the standard form, but I could have also used this one, and both those methods will get you there. I think this can be factorized as that. But you can use the formula as well. But just for time, I want to know what is the answer, what are the x-intercepts for this graph? So x is 1 is definitely one of them. So x is 1, or x is what? So x is 1 or x is 3. So in the next lesson, we talk about drawing graphs. These skills will be very important, but we definitely know how to find the intercepts for a graph. We also know how to change between different forms of a parabola. And we know a little bit more about how we can shift basic parabolas from this first half of the lesson. Pateko, you can use the quadratic formula. So this is a quadratic equation. And so you absolutely can use this formula. It will work. And in fact, it's probably more reliable than factorizing. So you absolutely can. But Chep was asked, I don't understand how you got the y-intercept as 3 and not minus 3. Okay. The key idea about that is to know, do you agree that minus 2 times minus 2 is plus 4? That's the main idea. So when I multiply this out, can you see I get to 4? And then when I take away 1, that's how I get to my 3. Whereas you're thinking, oh, I just go minus 2 minus 1, but that's not what's happening. This is actually 2 brackets and they have to be multiplied out. So I hope that helped a little bit for Chepo. Okay, everyone, it's time for a break. So I want you on your feet and I'm going to do the same. And that was a solid half an hour of maths. I can feel your brains saying, please give me a break. So that is what I'm going to do.
Please turn on your cameras, guys. Join in on the stage.
Let's see those
you
faces.
Mind a break.
I want to see those happy faces. Or not even happy. I just want to see those faces exercise. Happy maybe a lot to expect this time of day. Okay, everyone. So let's just do something that relaxes you. So I like swinging my arms, but you don't have to do that. You can do whatever. Maybe you want to swing your arms this way, or you can twist a little bit. Whatever kind of just gets your body moving so that your body knows you're not sitting down anymore. Maybe just shake it out. So shake out your arms, shake out your legs. Somehow shaking your legs out is quite helpful for blood flow. Yeah. Okay, so maybe choose your favorite one again and just make sure your body is moving. And then let's do a tricep stretch. Feel your stomach and feel your triceps should be getting nice and tight. And then you can switch to the other side. So, okay, and let's do small circles with the arms. Look out in front of you, and then as you're going, you can make bigger circles. And then change direction, so small circles going the other way, and then big circles. Okay, so hopefully your body feels a bit looser now, so let's do some high heart rate stuff. Let's do the air skipping. So you've got your skipping rope, and we are going to do 20 air skips in 3, 2, 1. 1, 2, 3, 6, 7, 8, 10, 11. 15, 16, 17, 18, 25 more. 1, 2, 5. And whilst it was only a minute or so, I do think that the return on investment is good for that. I definitely feel more human, so I hope you feel more human too. Let's do a little brain break. So here is the challenge for today. What is one Ninja Turtle plus another Ninja Turtle plus a piece of pizza going to be equal to? See if you can figure that out. So Zani is on speedy tonight. Let's see. 22 for this. 22 for that. Which means this has to be 2. Now, what is this red guy going to be? So I think something times 2 is 0. So then this has to be 0, which means this has to be 0. Yes, Linda, I agree. The turtle head has to be 0. So we've got 22 plus 0 plus 2 is going to be 24. That was actually not too hard today. That one, I like the pictures, but the maths was maybe a little bit too easy. But that was good. I like
Nicely
it.
done, guys.
Okay. All right. Then we've had a bit of a physical break. We've had a bit of a mathematical break. Let's go back to playing with some of these parabolas. So what I want to do now is I want you to find me. Okay, first of all, let me ask you some questions. Is this a happy or sad parabola? So if I say the g of x equals minus 2x squared plus 8x plus 20, is it happy or unhappy? It's unhappy or sad, and the reason it is because of this minus 2. Okay, all good. I want you to find me the y-intercept and the x-intercept of G. So go ahead and find me the y-intercept and the x-intercept of G. I see. Also, another way of saying it is concave down. Yes. So sad or unhappy, or the more official term is concave down. Yes. So the y-intercept will just be 20. No problems there. What's the x-intercept going to be? I guess I have to solve this. And I do think in this situation, probably the formula would be, well, it depends on everyone's different. So what do we get as our x-intercepts? So I see lots of students are getting x is -1 and x is 5. It looks, let's just see. So what we can do is we can check, let's just make sure we're on the, so we want to make sure our delta values are the same. So it's a plus, so 4 times 2 is 8, and 8 times 20 is 160. And then we get 220. We should have a messy number. Why am I getting something a bit different? So just check that you get a delta value of 224, unless I'm being silly. Because 160, no, it's not, no, it is 160 plus 64 is going to be 224. And what that means is that my answer can't be a nice, neat 5 and 1. So for Tekel, you could take it to the other side. So what you could rewrite this as is 2x squared minus 8x minus 20 equals 0. And it should give you the same answer as the other one. But because delta, so this thing inside the square root bracket, because it's not a perfect square, it's going to be a bit of a messy decimal. And we should get x is minus 1.74 or 5.74. So what we have is we get minus 8 plus the square root of that divided by minus 4, and minus 8 minus square root of 224 divided by minus 4. And we should get that x is equal to those two. Now, on some calculators, you'll get it in terms of, so level, you can also do that. Some of you will have divided by minus 2. So there's another way of doing this. You could have divided through by minus 2, and then you would have got x squared minus 4x minus 10. Now, why is that not working? So where are we going? So x squared minus 4x minus 10. Oh, yeah, okay. And so you could have done this one. And then you would have used a formula, and you would have got the same answer as us. So Lebo, you should have got the same answer as us. Did you get the same answer? I'm pretty sure that you did, if you did it correctly. You didn't. Oh. Just double check, because you should have. Let's just, maybe you made a silly mistake there. So while you're working on that. Oh, okay. I need to check. Maybe people made some silly mistakes. Okay, let's do this all again together. So if you go into your calculator, you should have minus 8 plus square root 224 divided by minus 4. And what do we get for that? So minus 8 plus square root 224 divided by minus 4. And everybody put what they get in there in the chat. So people are getting positive 1.7. I haven't worked this out, so I need to just make sure that we confirm this. So some people are getting negative. Where's my calculator? Here. Yeah, I found it. Ooh. I just found one. Let me just make sure. Oh, guys, I've suddenly lost. There we go. Okay. So if I go minus 8 plus square root 224 divided by minus, I get minus 1.74. So minus 1.74, or the other one is going to be minus 8 minus square root 224 divided by minus 4, and I get 5.74. Those are the correct answers. Okay, now I want you to do the same thing again, but I want you to do this time for a different parabola. So let us go to the g of x. So there is the g of x, and I want you to find me my y-intercept, and I want you to find me my x-intercept for this parabola. Don't worry, Kayleen, that's why we're here. And what's nice about it is we all do it together, and then we can easily spot our mistakes. But that's part of the learning process. It can level, indeed. The good news is when your teacher's mark, you would only lose 1 mark. You would still get some stuff. Okay, let's find our x and y intercepts. And let's go to Andile. Andile, I see your hand is raised. What's your question?
So for the first one, where negative 2x squared plus 8x plus 20, so
Yeah.
I divided all of it by negative 2.
Okay.
And then I got x squared minus 4x minus 10.
Okay,
And
x
then
squared minus 4x minus 10.
Yes, sir.
Wait, minus 2, I agree with that. I agree with that. Perfect.
And then I
Yep.
factorized it. So then I got x minus 5 and x plus 1.
Okay, here's the problem. 5 times 1 doesn't give you 10. So it's just because your factorizing wasn't correct. That's the only problem.
Okay, sir.
You see that? So
Yes, sir.
this doesn't factorize, but I understand. I almost did the same thing myself, so I understand. Okay, let's find the y-intercept and x-intercept. Now, this is written in alternate form, in the alternate form, so we have to be a little bit careful. To find the y-intercept, I make x naught. So I go naught minus 5 squared plus 4. And now I have minus in front, and I have 5 squared plus 4, which is minus 25 plus 4, which is minus 21. Sneaky, sneaky. So this negative is what is causing havoc. So watch out for that. Now, what is the x-intercept going to be? And there's 2 ways of doing this. I'll let you have some time to figure it out. So the thing, Deco, that I think you might have done wrong is that you should have got the 25 and then put the negative in front. So that was the problem. Your minus 5 squared essentially gives you this thing here, or it's the same as 5 squared. I suppose I could have just written it like this, sort of. And that thing is 25 with the minus in front. Then plus 4 is minus 21. So basically, if you're at negative 25 and you add 4, you don't go more negative, you go less negative. That's what happened. So to find this, I think we have to solve this one. So some of you are going to want to change it to standard form, and some of you are going to do it using squaring both sides. I'll show you both methods. So there's method 1 and method 2. So method 1 is probably going to be, no, I think actually most students are going to multiply this out, I think. So what you're going to do is you're going to write it like that, and then have the 0 on this side. Although I could be wrong if you feel like you would have done it a different way. So some students are going to do it like that, whereas some other students are going to bring the 4 across, and you're going to get that, and then you're going to divide both sides by the negative and get that. I'm not sure. Tell me in the say M1 if you are doing this way, and say M2 in the chat if you're doing that way. Okay. All right. I'll show you get the same answer in both ways, but So I'm going to leave the minus in front, and this is going to be I'll give you a bit more time. Yeah, that was quite a bit of work, eh? Now, the question is, can we, I think some of you would even move it across to the other side to make it, it's not going to be plus, it's going to be minus. So minus, and then it might have been quicker to use the formula, but we should get x is 3 or x is 7. So Linda, what we're trying to do is we're trying to find the x-intercept of this. Let me zoom in so that you can, oh, that's a bit much here. So let's bring that back. So we're trying to find the x-intercept of this graph here. And what we did was we made y naught, but that was, it's not wrong, it's lovely and it's correct. But I will show you that another way of doing it, which was a little bit quicker, but I don't know, it probably is more reliable to stay with method 1, is if you square root both sides at this point, the square root of 4 could be 2 equals x minus 5, or you could have minus 2 equals x minus 5. Because it's basically what you're doing is you're square rooting both sides here. Because you get positive and negative 2 as an answer. And then when you square root it, the x squared goes away. If you bring the 5 across, you then get 7 is x. And if you bring this across, you're going to get minus 2 plus 5, which is 3, which is x. And so the good news is that both answers are the same, but it's just something to bear in mind that sometimes with parabolas, if you want to find the x-intercept, it can be quite quick to square root both sides, but what you've got to make sure you remember is that you have both a positive and negative. But if you're at all unsure, stick with the longer, more reliable way. Okay, do we have time for one more? So how did 25 become 21? Because it was positive both sides. Okay, so it's got to do, the 25 is the from the minus 5 squared, but there's a negative in front, which makes it negative 25, and the plus 4, when added to negative 25, gives us the negative 21. Okay, you know what, guys, I'm actually going to stop there for today. In the next lesson, this is what we're going to do. We are going to take parabolas and straight lines, and we're going to just make sure we know how to find the intersection points between them. And then I'm going to show you a 5-step process for drawing any parabola. And all we're going to do is we're going to draw 5 or 6 parabolas in the next lesson. And by the end of that, you'll be super waxed in drawing parabolas. Today was just about making sure you know the algebra to find the x and y intercept, and also to make sure you had more awareness of parabolas. And so that was the goal for today. So I hope that that was helpful in building your understanding. You won't become a ninja in functions in one lesson. You need to keep building up your skills. But it felt like today we had a solid foundation.